Welcome to the Titus Timeout podcast. I'm Matthew McLaurin. In this episode, we'll be discussing the use of recirculating units in patient rooms. As a brief recap from a previous podcast, there are prescriptive requirements for healthcare facilities. These requirements are part of ASHRAE Standard 170. For patient rooms, the design temperature is specified to be between 70 and 75 degrees. Relative humidity must be maintained below 60%. And air supplied to the space must be filtered upstream of the AHU coils by a minimum of a MERV 7 filter. Downstream of the air handler cooling coil, a MERV 14 filter or better must be used. Standard 170 also has prescriptive requirements for air changes. 4 total air changes are required for most types of diffusers. 2 of these must be outdoor air changes. Room recirculating units such as fan coils, PTAC units, VRF, and chill beams can be used to achieve the additional air changes. However, there are some additional requirements. These units must not receive non-filtered, non-conditioned air. In other words, any outdoor air supplied to these units must be filtered and conditioned in the same way as rooms using all-air systems. The recirculating unit can only serve a single space, and a filter with a minimum rating of MERV 6 must be supplied for units with airflow designed to pass over a condensing surface. At this point, the real question is, why would you use a room recirculating unit? To get a better understanding, we will look at the energy requirements for an all-air system and a recirculating system. First, let's consider the all-air option for a room with a cooling load of 20 BTU per square foot. To treat that with a VAV system, that would require about 5.5 air changes. In this example, we'll use a chill beam for the recirculating unit. You'd supply 4 BTU per square foot with the primary air, and the remaining cooling would come from the recirculation of room air over the coil. Since the room won't always be at design load, we must also review part load conditions. Considering that the minimum air change rate for the VAV is 4 per hour, we can start there. The all-air system would be delivering 14.5 BTU per square foot. This is the maximum turndown for the system. While the chill beam is still supplying 4 BTU per square foot with the primary air, the balance of the cooling is provided from the coil in the unit. Next, we'll consider the maximum turndown for the chill beam. This would be with the water flow to the coil off and only supplying the primary air, which would do 4 BTU per square foot of cooling. The VAV system at minimum turndown would supply 14.5 BTU per square foot of cooling, but would need to also supply 10.5 BTU per square foot of reheat to prevent overcooling in the space. The elimination of the parasitic reheat is the single largest reason for hospitals to utilize room recirculating units. In most cases, you can reduce the reheat energy requirements for a building by 60 to 70%. There have also been hospitals that have shown the ability to reduce the reheat cost by as much as 88%. This reduction in energy usage is one of the main reasons for the increased use of chill beams within patient spaces where allowed by ASHRAE Standard 170. For more information on air distribution and critical environment applications, please check out our e-learning site or our YouTube channel. Don't forget to subscribe while you're there, and thanks for taking the time out with us.